So good morning. Welcome to day 2 of second semester. For those of you in person and watching the video live in class today, these are your grading mods. Okay, so Wednesdays, whatever time you have class on Wednesdays, for those of you watching at a later time, those are your grading mods. So I am your grading teacher. For me and my grade book, and I think this goes for the video watchers too, my grade book, you might not see it right away in third quarter, okay? Because my grade book is actually in fourth quarter, okay? Because we run a semester-long grade book, so it's automatically generated in the fourth quarter. So if you don't see your grades or something like that, or you're looking for your grades, you got to switch over to fourth quarter, okay? One big note here, there is a formative this weekend, 2-questioner. It'll be on a Google Doc. Do the work, take a picture, put it in the Google Doc, etc. And then another video to watch and take some notes. I believe that the video is under 15 minutes. So between Friday, somewhere between the end of class tomorrow and before class on Tuesday, okay. All right. And then a must that you need here, if you don't have a pink trig identity sheet, there's one on, for those of you at home, the identity sheet is the reference chart that we were referencing yesterday. There's one on the learning page. Does everybody here have one? You don't have one? For everybody else, yeah. Or if you're a B student, you need to get one next week. We have them in school. Okay. All right, let's do this. So, fractional fun. Go for it. Warm it up. Anybody need more time? Fantastic. Okay, what's my common denominator? Common denominator? What we got? Go ahead. First one, what do I need on top? 1 minus sin x. Second one, what do I need on top? Okay. Those are both being multiplied by 1, something like that. Okay. Then I add the top, if memory serves me right. 1 minus sin x plus 1 plus sin x all over 1 plus sin x, 1 minus sin x. Yahoo! Yes. Okay. Then what does anybody do? So yeah. Negative sin x plus sin x is 0. Love it. Okay, so then you do 1 plus 1 on top right away too? Okay, love it. Okay, so then you got 2 over, and you said you multiply the bottom, and did you get 1 minus sine squared of x? Okay, that's good. That's what I got. Okay. Then what? Or are we done? So what? Cosine squared of x, is that what you're going to say, Hopper? Love it. Are we done? or can we go even further? I would say we could go even further to just 2 secant squared. Would be my guess, or my preference. Okay. Love it. Okay. Let's try this one. Let's do this one together. Okay. So we need a common denominator. What is going to be our common denominator? Tangent of x? No. First fraction. Do I need to add anything to the numerator? Yeah? Okay? Nope, we're already in there. Love it. So that's going to stay. Second fraction. Do we need to add anything? Becomes a square root. In this case, we're subtracting the top. You want to tweak secant, or do you want, you want to tweak secant squared, or do you want to tweak tangent squared? Secant squared? What is secant squared? No, even better. Tangent squared plus 1? Yep. Secant squared is tangent squared plus 1. Like that. Numerator simplifies to be 1. Okay? And what is 1 over tangent of x? Cotangent. Love it. Okay? You try this one on your own. Yes? Everybody start with that? Then I probably would have went to that. First one needs a cosine and another cosine added to the top, or multiplied to the top. So we get cosine squared there. Combine the top. That. Cosine squared plus sine squared. cosine is C. Yep. Moving on to complementary angles, thinking back to when you were in geometry, or even possibly before you were in geometry. Complementary angles are two angles whose sum adds up to be 90 degrees. Okay? If we wanted to represent those angles or those complementary angles algebraically, we wanted to represent those algebraic angles, or represent those angles algebraically, I should say, we would have our original angle theta, and it would be in degrees. Okay? And we have to add to it another angle in degrees, and that would be, the sum there would be 90. Well, that other angle is always going to be 90 minus theta. Okay. So theta plus 90 minus theta is always 90. Okay. That's how we would represent it algebraically. If we were doing this in radians, then theta would now be in radians, but instead of adding 90 minus theta, we would add pi over 2 minus theta. And that would equal pi over 2. Okay. Now, I'd like to show you a cofunction again. Okay. So, if you had a calculator, okay, if you have one, get one out. Yeah. Make sure it's in degrees, first off. Okay, make sure it's in degrees. And you find me the sine of 20 degrees. And I'm going to find the cosine of 70 degrees. Everybody got it? They should be, or they both should be, I'll read mine off and you tell me if I'm right, 0.342, 0.20143. You got for the sine of 20? That's what I got for the sine of, or excuse me, for the cosine of 7. Okay. You give me the sine of 42, I'll give you the cosine of 48 degrees. Should be 0.669130606. You do the cosine of 22, I'll do the sine of 68. 0.927183855. Double tick. Yes? Are you getting those on yours? Okay. Because sometimes if you're like the grapher usually defaults to radian. Okay. Otherwise, do you know where this degree symbol is? Either way. Okay? So those are what are called cofunctions. reason that happens is in a right triangle, if I'm down here at angle A and you're up here at angle B, and you remember SOHCAHTOA, okay? So if we call this side B, this would be side A, and then this would be my hypotenuse. Okay? So the sine of angle A is going to be the opposite side, A, over the hypotenuse, is B. The cosine of angle B, I go to the other one now. Cosine is the adjacent, which would be side A over the hypotenuse. There's a right triangle relationship that gets us to pull a function. Now, what that leads us to is numbers 12 through 17 on your identity. So these are the cofunctions. And the nice thing that you will always see is you would always see what's inside the parentheses there. Okay? It might be a different letter instead of U, okay? But you'll always see that, or you would see 90 minus. Okay? So, with that being said, let's now the sine of negative x times the secant of pi over 2. Right there. Okay. So, utilizing my identity, sine of negative x is negative sine of x. Would you agree? Identity number 2. Secant of pi over 2 minus x, number 17, becomes cosecant of x. Would you agree with that? Yeah. Cosecant is 1 over sine of x. So now I have sine of negative sine of x times 1 over sine of x, and that, the signs cross each other out. Negative 1 times positive 1 is negative 1. Okay? Love it. You try this one now. So sine is sine. Tangent cosine is sine of theta over cosine of theta times cosine of theta. And cosine of pi over 2 minus theta, according to number 13, is sine. Does everybody agree with that? Sine is still sine. Sine is still sine. Sine over cosine times cosine becomes sine. Sine of theta minus sine of theta plus sine of theta is cos. Isn't that cool? That big, long, ugly thing really is just sine of theta. So really, negative tangent of theta cosine of theta plus cosine of pi over 2 minus, that cancels each other out. The last two terms cancel each other out. Awesome. I love this stuff. Okay. Okay. So, what you have now in your pink packet that you got, if you were a B student, you got last week. If you're an A student, you got yesterday. You've got the first sheet of paper, both front and back, that you can be working on now for the next mod. Okay? Okay? And then equations will hit up starting later on this week. Okay? So we got all that.